Hello, my people. I want to welcome us back here again. This is still your mathematics class with your tutor Michael. Now, continuing from where we stopped in our last video. Please, if you have not watched that video, do well to go back to that video and watch it before you come back to this one we are going to talk about. We are still looking into the concept of numbers, and last time we stopped at rational numbers, all right, in the family of numbers. Today we are going to be looking at the opposite, which is irrational numbers. That is the opposite of the last we talked about in our last video, which is opposite of rational numbers, which is irrational numbers. And irrational numbers are usually represented with the letter P. Yes, mostly it is represented with the letter P. Now, what are irrational numbers? We say that irrational numbers, like we defined the rational numbers to be numbers that can be written in the form P over Q, which is as a fraction, whereby we gave some qualities that those fractions should have for you to call them rational numbers. Now, irrational numbers are now defined as numbers that cannot be written in this form. Please take note. Numbers that cannot be written in the form cannot be written in the form P, that is, cannot be written in the form P over Q, that is a fraction. So they cannot be written in this form. Though there are some irrational numbers that we can easily say they appear as fractions, but there is major thing that categorizes rational and irrational numbers from our last video. Now we have these numbers. Irrational numbers will include numbers such as root 2, root 3, something root 5, pi, which is the measure of, that is the ratio of the circumference of a circle to its diameter. That is the circumference of a circle all over the diameter of the circle. And approximately, it is usually given as 22 all over 7 or 3.142 in a short form of it. So pi is an irrational number. Now, there are also other ones. Root 7 is also an irrational number, and as many as they can be. One thing you should discover about all these numbers is that when from checking from our last videos, where we said that the pattern for rational number, that the pattern of their decimal are repeated. All right, the pattern of their decimals are repeated. If you check from these irrational numbers, you will see that all their decimals have no repeated patterns. They are different numbers, and they are also endless. They are also endless. That is what we can say about irrational numbers. We have another form of number which we call the real numbers. Now, the real numbers are usually denoted by the letter R. And what are real numbers? Just as the name implies, they now include all numbers from the natural numbers, the integers, the rational and irrational numbers. All are real numbers. But the real numbers now include all decimal numbers, both rational, irrational, and natural numbers and integers. They are all real numbers. So the real numbers will include the natural numbers, which we represent by the letter n. They will also include the integers, usually represented by the letter z. They will also include the rational numbers, usually represented by the letter q. They will also include the irrational numbers, usually represented by the letter P. So all of them can be given as they are all members of real numbers. So all these numbers inclusive are real numbers. Please, whenever you see this in mathematics, it means is a member of. All these are real numbers, including all fractions or all decimals. They are all real numbers. Now, another form of number we talk about here is complex numbers. And complex numbers are usually denoted by the letter C. The letter C represents complex numbers in mathematics. And what are complex numbers? Complex numbers now includes all numbers from the natural numbers down to the real numbers. All numbers from the natural numbers down to the real numbers. Of course, since all natural numbers, integers, rational, irrational numbers are real numbers. So we can say that all real numbers are complex numbers. But there is a difference. There is something that makes complex numbers unique. Alright? And what is that particular thing? Complex numbers contains the real and the imaginary part. And what are those real parts? The real parts can be written in this form. For example, if we have 2 plus, we can write 2 plus 2i, where 2 here is the real part of this number. And this 2i, this one containing the I here means imaginary. So this one is the imaginary part. And how come about this imaginary? This is another important thing we need to talk about. How did we come about this imaginary in complex numbers? Now, the imaginary in complex numbers came about when we have the square root of negative numbers. For example, the square root of -4 cannot easily be gotten. Alright? The square root of -4 cannot easily be gotten. So the square root of -4, if we try it, it will give us undetermined answer. Mathematics now try to bring a solution to it, making it appear useful in mathematics, even though in reality they may not be useful. But then trying to bring out another concept in mathematics. So that brought about what we call complex numbers or the imaginary. Now they now have to separate this square root of -4 are now being separated as square root of -1 times square root of 4. Of course, the square root of -1 times square root of 4 will give you the square root of -4 that we have here. Now, what happens now? Square root of 4 is given as 2, and the square root of -1 cannot be gotten. So we call it imaginary. Of course, as the name implies, it is just an imaginary number. It doesn't exist in reality. So the square root of -1 becomes an imaginary. Some textbooks can use it as j, but of course, the I best represents imaginary. So when a number contains both the real part and the imaginary part, we say that it is a complex number. So numbers like 2 plus 2i or 2 plus i2 is a complex number. We may have also numbers like -3 plus I is also an imaginary number. Now, what we have to see here is that all numbers from the natural numbers down to the real numbers are complex numbers. And why do we call them complex numbers? Because they are imaginary. For example, all the whole numbers like 2 has the imaginary part as 0. 2 as a whole number, its imaginary part will be 0. Just to make it, to bring out the complex part of it. So all natural numbers down to real numbers are complex numbers. So linking up all the families of numbers that we have discussed, we can start from the natural numbers. we say that the natural numbers are subsets of integers, and integers on their own are subsets of rational numbers. Yes, integers are subsets of rational numbers. Of course, we have the irrational numbers. Then the rational numbers are subsets of real numbers, and the real numbers on their own are subsets of complex numbers, which is the highest form of numbers that we have. Or we can just write them this way. The natural numbers are members of the integers, and the integers are members of the rational numbers, and the rational numbers are members of real numbers, and real numbers on their own are members of complex numbers. And this concludes it about all the families of numbers that we have. Now, this may bring this to an end, but in our next video, we are going to be talking about other forms of numbers like prime numbers, odd numbers, then the composite numbers, which are the opposite of prime numbers. So please do stay connected on this channel. I remain your online mathematics tutor Michael, and I hope to see you in our next video as we continue enlightening you on the basic concepts of mathematics. Please do stay tuned and see you on the next one.